So far in geometry, we've been talking a lot about triangles, which is a three-sided shape. So in this unit, we're going to talk about polygons that are higher than three sides, and more specifically four-sided polygons called quadrilaterals. Before we get to that, we're going to talk about just in general polygons, how we classify them, and how we can find the interior angle sum, the sum of the interior angles for any polygon. Okay. So first let's look at the definition of a polygon. So the polygon really just means many angles, so poly means many, and gon means angle. So many angles. So a figure can be classified by a polygon in two different ways. So we have a convex polygon, okay, and concave polygons. Now a convex polygon is any shape that when you extend any segment to make a line, so any of the sides to just extend out, no part of that line will be in the interior of the polygon. Concave would be the opposite. So when I think of concave, I think of a cave, so it's like a cavern. If you look at the shape, so it kind of dents into the shape. Convex would just be the opposite, so nothing is really caved in, it's just all sticking out. So another way we can check is if we, like it said, extend the segments. So if this first triangle, if I were to extend all the sides are extending, you can see that none of the lines are within the triangle. They're all going to be outside of the triangle. But if I look at this shape, this plus sign here, this cross, some of the sides are fine, right? If I extend that one, that looks good. But let's say I wanted to extend this right here. So if I extend that, you can see that it actually intersects with the interior of the polygon, this part here, which is not good, meaning that it becomes a convex or concave polygon. So this is concave. This is convex. Okay. Now this last one, you can see if I drew lines across all of its sides and extended them, none of them would really cross on the inside of my polygon. Okay. So a convex polygon can also be regular. Regular means that all the sides and all the angles are the same. So if I were to mark this shape here, I have 1, 2, 3, 4, 5, 6, 7, 8. So I mark them all as equal. And if I marked all the angles as equal to each other, this would be a regular polygon. And I counted that it's 8 sides, so I would say this is a regular octagon. Regular polygon. Another term we're going to be using to describe the properties or segments in a polygon would be the diagonals. Now this is going to be an important measure or segment because it'll help us find the interior angles of a polygon. So the diagonals of a polygon is just a segment that connects two non-consecutive vertices. You can leave it as non-adjacent as well. So that means vertices that are not next to each other. So I'm just going to pick one point here. So let's say at this vertice, I'm going to connect another vertice that's not next to it. The only two that I see would be the one over here and that one there. This one would be next to it, and that one will also be next to it, so I wouldn't count those as diagonals. If I chose another color just to differentiate, let's say I chose this vertice, the two diagonals would be here, here, you can see that from this vertex, I already have one that's drawn. Another one that's not drawn would be this one here. Okay. The one that goes right all the way to the bottom left. So those are your diagonals in a polygon. So we're going to use these diagonals to figure out the sum of the interior angles. So let's see how we can do that. So what we're going to do is, for each of these polygons that are given, we're going to draw all the possible diagonals only from one vertex. Okay. So we're just going to pick a vertex and we're only going to draw diagonals from that one. Okay. So for the square, let's say I pick this vertex, the only diagonal that I see would be the one that's straight across. And that would be it for diagonals. For this 5-sided shape, which we call a pentagon, if I chose that vertex, the two diagonals would be here and here. Everything else would not be a diagonal because it's adjacent to the vertex. Now I'm going to go through and draw the rest of my diagonals. So there you have it. There's all my diagonals in the shape. And as you can see, each of these diagonals created a triangle or number of triangles within the shape. So for the first, we have a square. And in the square, how many triangles do we see? We can see that in the square, it's created 2 triangles. The one on top here and the one on bottom. So we're going to fill out this chart. For a 4-sided shape, which is that square I had, I created 2 triangles. What if I had 3 sides? If I had 3 sides, that's a triangle. How many triangles can I draw in it? Well, in a triangle, there are no diagonals that I can draw. So there's only one triangle within a triangle. So the number of triangles, 1. For 5-sided shapes, I can see that if I count, I have 1, 2, 3. That is 3 triangles, and you can start seeing a pattern here. 6-sided shape has 4 triangles. A 7-sided shape has 5. 8-sided shape has 6. So following this pattern, what if I had n sides? If I had n sides, looking at my pattern, it looks like the number of triangles is always 2 less than the number of sides. So if I had n number of sides, you would have n minus 2 triangles. Okay, let's go ahead and look at the sum of the interior angles now. Let's see how we can figure it out. With the triangle, if there's only one triangle in there, we know that all triangles have to have a sum of 180 degrees. Now for a 4-sided shape, if you already know that it's 360, that's great. But if we don't, you can see that we have 2 triangles. Each triangle has to have 180 degrees. So if I did 2 times 180, you would get 360 degrees. So what about a 5-sided shape? So in a 5-sided shape, we have 3 triangles on the inside. So if I did 3 times 180, you would get 540. And we're going to do that for the rest. So finding the number of triangles, I have 4 times 180 gets us 720. 5 times 180 will be 900. 6 times 180 gets us 1080 degrees. if I were to write a formula, we would be taking the number of triangles multiplied by 180. So we can see that the number of triangles is n minus 2, so it would be n minus 2 times 180 equals your formula. So that is your formula for any polygon to find the sum of its interior angles. So the sum of the interior angles, if S is the sum of the interior angles of a convex polygon, so it must be convex, no concave polygons, then S equals n minus 2 times 180. In class, we'll talk more about some of the interior angles and how we can use this to find the exterior angles.